Hi, how are you? This is Boik. First of all, I want to thank you all for listening to my talk. And it's my pleasure to be here to share my recent work to you. And today I'm gonna talk about how we can use CodeQL to discover vulnerabilities and do variant analysis. So hi again, my name is Boik, and I'm from Taiwan. I'm currently the security researcher at SciCraft. Also, I'm one of the members in ChangeRoot, a private security research group in Taiwan. Besides, I'm a programming lover. So if you are interested in any projects or researches that I'm working on, you can check out my GitHub or follow my Twitter. So here is the agenda for today's talk. At first, I will briefly introduce the background knowledge and the terminology of CodeQL, including some basic features and examples. Next, I will demonstrate how you can use CodeQL to discover vulnerabilities and to find things that you are interested in. It is also helpful to be used in SDLC. Later on, I will talk about a vulnerability that are successfully found using CodeQL. So this vulnerability has basically impacted several hundred websites. So I will give out some detailed explanation in this part. At last, there will be a conclusion to sum up today's talk. Okay, so let's get started. So the first part is, what is CodeQL? I believe that many of you have heard of this tool before, since it's commonly and widely used by many security researchers and many big brands such as GitHub, Intel, and Mozilla. This is a brief overview of how CodeQL handles both extraction and evaluations. As you can see, that a code base is extracted by proprietary extractors and stored as a snapshot database. And each database contains one queryable data extracted from the code base for a single language in a particular point of time, which means that if a code base contains multiple languages, you can have a database for each language. And two, a copy of the code to show the query results on. So once we get the database, we can use pre-made queries developed by SAML or community. Or we can also write our custom queries and use them in many ways. So here's the query structure. So CodeQL syntax is very similar to the SQL language, and is comprised of these main parts. The first one is import. So import, basically at the beginning of the query, you will use import to import extensive libraries that we are about to use in the following context. And then from. From is the place that we declare variables that we are holding our interested values for calculations, such as function, function code, variable access, variable, and expression. Then where, once we have defined CodeQL variables, we can then construct the predicates to be applied on them. Although this part is optional, it is also the core of the query. And finally, select. Under this clause, we set how the output is going to look. We can bind CodeQL variables and present them in different ways. And usually, we are put it in a table. So CodeQL has provided extensive libraries to let you write your custom queries to do variant analysis, including static analysis, data flow analysis, tent analysis, and control flow graph analysis. So you don't have to worry about supported languages. CodeQL has provided many common languages support at the current time. Additionally, CodeQL is not the kind of tool that will help you automatically find the vulnerabilities for you. It is a tool that will help you simplify the process. You don't need to prepare the environment and the tools to do the analysis. which is really exalted if you had experience on it. CodeQL benefits you by providing well-organized extensive libraries to let you run your custom queries. So our first analysis is called static analysis. It is basically the very straightforward methodology for analysts to do this analysis. So it is very easy to use, and you can use it to find static things among the snapshot database. It is very fast and accurate to find flows that don't require complex requirements to meet. So it is better to use this way to find like hard-coded password strings, misuse of dangerous functions, and etc. So check out the examples here. On the left, we write a simple query to find all the occurrence of the function. Code executes. While on the right, we write another simple query to do the search for hard-coded password. So these queries are simple but very helpful if you are searching for like low-hanging fruits, and it did return some results back. And this one is more complicated than before. So we extend the class from invoke expert, a predefined class in CodeQL to find all objects that are invocable, such as functions or constructors. So this extended class will try to find all occurrence of regular expressions that contains dot star. So why do we want this? It is because that some developers would write down this regular expression, but want to match the real dot actually. So this is really a common pitfall for especially junior developers, though seniors might make the same mistake too. Data flow analysis is used to compute possible values that a variable can hold at different points in a program, determine how those values propagate through the program, and where they are used. So therefore, this feature will let us evaluate in different points the fate of some line or insecure data if data is misused in dangerous functions, which will reveal some possible leaks or impactful flow. So besides, it also lets us to understand the other aspects of how a program behaves, which leads to possible intriguing paths maybe. So this query is a lot complicated than the one that I presented before, and it is to find interesting functions arguments that are controllable by users' inputs. So with this query, I'm able to see how program will behave after receiving my inputs. Okay, intent analysis. So intent analysis differs from basic data flow in that it considers non-value preserving steps in addition to normal data flow steps. For example, in the assignment, y equals 10 plus comma plus 10. If x is tended, then y is also tended, even though there is no data flow from temp to 10 plus comma plus 10. So temp tracking is in the temp tracking module, and any temp tracking or data flow analysis query has three implicit components, one of which is optional and an implicit component. The explicit components are, first, one or more sources of potentially insecure or unsafe data, represented by the temp tracking source class. Second, one or more sinks to where the data or tent may flow, represented by the temp tracking sink class. And the third, zero or more sanitizers, represented by the sanitizer class. So a temp tracking or data flow query gives results when there is the flow of data from a source to a sink, which is not blocked by a sanitizer. So these three components are bound together using temp tracking configuration. The purpose of this configuration is to specify exactly which sources and things are relevant to the specific query. And the last one is control flow graph analysis. To be honest, I don't see many use cases about this, so I will just skip this one. But if you are interested, you can check out the CodeQL's page about the infos about the usage of this one. Now I will talk about practical usages of CodeQL. They are basically things that I do every day to help with my research. So my first trick is replicate CVEs to find new CVEs, which basically means that we can model threads to find them somewhere else. So why would we do this? It is because that some vulnerabilities were faced by vendors by just mitigating reporters' reported cases. And by replicating these vulnerabilities by modeling with CodeQL, it is possible to find the same flow through other cases. And be mindful that you have to write your query more generalized so as to find the same loopholes in other repositories or other code bases. So this is what we call variance analysis, the process of using a non-vulnerability as a seed to find similar problems in other code bases. And there are many variance analysis reports on GitHub Security Lab. If any of you is interested, I personally recommend you take a look at them. Okay, so let's check out this one. So this report is actually grabbed from HackerOne. So it says, Keybase hostname validation regular expression. All right, so it's actually the regular expressions used in Keybase extension. And look at these two regular expressions. Could you identify the vulnerability? Let me give you a few more seconds to think about it. So let's brainstorming. Okay, you found it? All right, so the issue stems from the fact that it used dots instead of the real dots in the two regular expressions. So it means that once a hacker owned a domain like totally.twitter.com, as you see in this picture, it can trigger the extension to pop out under the wrong context and to steal like the password or something. So how about let's model this flow? So the first step is to find all the occurrence. This case is very suitable for using static analysis, since we have said that before, that it is very suitable to use a static analysis to do search for static things. So right now we use static analysis to do the analysis. So step one is to find all occurrence. So we find all the occurrence of the regular expressions functions, constructor one. And then the step two, we find all occurrence with .start inside. So we just reuse the snippets that we wrote before. So after writing this query, let's apply to other code bases to see if it's possible to find out the same flow in other code bases. So, boom. Yes, I did find the same mistake in the Electron code base. So basically, these vulnerabilities impact the Electron from 1.2.2 to 4.2.12. So this regular expression failure upon checking the website's URL to activate the web extension. So Electron, maybe some of you have never heard of this before. So let me explain a little bit to you. So Electron is a framework built on top of Node.js and Chromium, so that developers write cross-platform desktop applications using JavaScript, HTML, and CSS. So the vulnerability here affects the same functionality provided by Chromium, so that developers load extensions in Electron. All right, so the patch is really simple. So Electron team just make sure that all special characters get escaped correctly, and that is fine. So here is another case that I found recently. Due to a penetration testing case, I stumbled upon this framework for the first time. Besides, I noticed that it used an endpoint to serve different types of static files. Not a common implementation, as you can see on the slide. So I use a base 64 encoded string to represent the real path that this library is about to load. So here is basically what it works. So we provided a base 64 encoded string of the path, and then it will return its content. So after checking the old vulnerabilities it had before, it seems that this library is prone to local file inclusion issues for several times. Seems to be a good target for us to do variant analysis. Besides, as you can see on the slide, Umbraco form seems to be a good target as well. But we will just do variant analysis toward client dependency this time. So this is how a local file inclusion issue happened to the client dependency library. Really straightforward, right? So we just give this library the path that is about to be loaded by this library. So for example, as you can see, we specify web.config to be loaded. And this library just read the content of it and send it to our response, to our HTTP response. So this is a local file inclusion issues happened before. So yes, the same, we just model this flow and try to find the same flow or the similar flow happening to this client dependency with the latest version. So before we model this threat, we need to know that in ASP.NET, it is common to implement the HTTP handler interface in order to intercept users' requests. And therefore, those classes are good sources for us to intercept users' requests. Because it will take too much of my time to cover all steps that I did about how I traced the code to find the root cause of these two vulnerabilities, I will skip them then. However, it roughly goes like this. There is a user-controllable input which will be intercepted by the classes implementing our HTTP handler interface. We call them source. And then there is a weak point that will read contents of files and send back as the response body. After reviewing the source code, we note that it is write file to string, so we set it sync. In this case, change analysis is definitely the go-to, After modeling with CodeQL to find those two old flaws, I could successfully discover a new one with the send CodeQL query with a slight modification. So the modification literally leads me to another possible bypass of its patch to those two vulnerabilities. So until this step, we successfully found a new local file inclusion issue within client dependency from 1.8.2.1 to 1.9.8. So let me show you some detailed query. So this one is source node. The left one is to find all methods that have the qualifying name starting with system.web.ihttp handler. And right on the right-hand side, source nodes are set as their parameters. On your left, things are set as the functions we mentioned before, the culprits of the previous two flaws. And the right-hand side is our actual additional tensor steps. It looks very complicated, right? It is. It is hard to explain all this, but this requires a lot of efforts to read the source code and understand the root codes of the vulnerabilities, and figure out how under what situations should the nodes to be tainted. I want to state this one more time. Don't consider the CodeQL is a tool that will automatically find vulnerabilities for you. It needs to be trained and operated by professionals by nature in order to find bugs. Apart from finding bugs, we can also use CodeQL as a pattern finder. Let me show you. So because CodeQL cited as a semantic code analysis engine, it is naturally that you can use it to find something that you are targeting. So these are common methodologies that we use in our daily lives. Let's check them one by one. So the first one, grab strings regular expressions. We are all very familiar with this, right? Grab to find something statically, regular expression to find something with patterns. Although they're easy to use, they are pretty vulnerable to false alerts. It is because that this kind of searching isn't context aware. And it is also hard to track back to the origins. The second one, UML class diagram. The UML class diagram is a graphical notation used to construct and visualize object-oriented systems. A class diagram in the Unified Modeling Languages, UML, is a type of static structure diagram that describes the structure of a system by showing the system's classes, attributes, operations, and relations among objects. It allows penetration testers to find the relationships of an object among other objects. And sometimes it is really useful when you are searching or you are dealing with Java or .NET-based objects, because they are basically object-oriented. So here are some class diagrams in UML. And here is a use case. So a typical case I come up with is the CVE 2018-1000-861, a Jenkins remote code execution vulnerability. So the rationale of the issue is the loose constraints set while doing routing matching and dispatching. You can see it on the slide that the stapler web framework staplers most objects to URLs. Therefore, all we need to do is to find good gadgets to chain all together to achieve remote code execution. And of course, we can use UML to get our head around this challenge. You can clearly see how it could be so useful in this case. All right, so here comes our CodeQL. So I have said that it gives you extension libraries to you, so it could be easily used to find things. Besides, it gives you results based on context, and therefore, these results are accurate and meaningful. So let me take the Umbraco case as an example here. I said that I successfully found a local file inclusion that affects client dependency from 1A21 to 198. Nevertheless, in order to achieve remote execution, we still need to find an entry point that doesn't require us to be an authenticated user. So how do we find an easy-to-use bridge to get remote execution? Yes, how about using CodeQL to find those pages? We can not only find unauthenticated accessible pages, but have a human-readable query to share to the community. Or we can also keep it somewhere for reference. So once we get a list of pages that we can directly access, all I need to do is to pick up a common page that every copy of Umbraco CMS would have. Umbraco pen.spx seems to be a good target. We will talk about how to achieve remote execution later. So here comes our last one, regression test. In this section, I want to talk about SDLC and how you can apply CodeQL to your SDLC. So what is SDLC? AKA S-SDLC is the initialization of secure software development lifecycle. Simply put, add security activities to the system development lifecycle, preferably in every phase of SDLC and formalized. If you have heard of DevSecOps before, it is actually part of it. So how could developers apply CodeQL to SDLC? Firstly, we can write simple queries to find hardcoded strings, sensitive data, API keys, or misuse dangerous functions, etc. Then we can gradually rewrite our existing unit test with CodeQL if possible. Or we could also just import LGTM sets of rules, especially the security one. Additionally, since CodeQL is a community-driven project, it is also possible to find others well-written queries from like public researches or public repositories. Following are some rules that are grabbed from the LGTM's official repo. So this one is to check if there exists any client-side URL redirection in the code base. The LGTM team has used this tagged analysis to track if a user-controllable input is possible to control to which the website will redirect. This is called open redirect vulnerability. And this one is to check if there exists any user-controllable inputs that will be read and parsed insecurely by a XML parser. So this often results in XSE injection, XML external entity injection. And this query is the outcome of a public research from Pentester doing a threat analysis against CVE 2018-16621. So this issue description said that a Java expression language injection vulnerability has been discovered in Nessus repository manager 3. He thought that is a good target for doing variance analysis, and he did find different kinds of variants EL injections at end. So the journey is fun, and you can learn from him by utilizing the CodeQL powerful libraries to circumvent a variety of limitations. So I highly recommend you take a look at it. And this one, utilize CodeQL to write a query that will find heap-based write buffer overflows caused by main copy. A sub-scion from CyberArk successfully discovered 7 new vulnerabilities in this popular open source framework, FFmpeg. Okay, so right now let's talk about the vulnerability that I found, the client dependency massacre. Because the vulnerability that I found actually affected the library used in Umbraco. Each and every installation of the CMS would possibly get affected, and the affected installations could be dated back to 2015. Do you know, even Microsoft used this Umbraco CMS for their forums like SP forums or RS forums. In fact, there are so many websites using Umbraco. So let's recap this vulnerability. Once we get a list of pages that we can access without authentication, all I need to do is to pick up a common page that every copy of Umbraco would have. And Umbraco pin.spx seems to be a good target for us. But how do we get RCE? We actually can get RCE by leveraging machine key. So first of all, do you know what is machine key? So machine key is like the golden key for various security operations in ASP.NET. It is like if you get to see the value of the key, you own the server. The key is used in various components and will be automatically and uniquely generated when you first initiate the CMS. Or developers can also specify their ones to support web forms. So if you Google how will machine key being misused lead to remote code execution, you will probably find some articles. Definitely all developers should pay attention to it, should know how dangerous it would be if you leak the key to attackers. So I said that the main components count on machine key to handle the decryption or the validation things. So one of the components, view state, is the one that I use that leveraged to get to the RCE. So view state basically stores client-based state, such as values or options. It is used commonly in web form architecture. Because ASP.NET uses machine key to decrypt and validate the underscore view state, or forms authentication and so on. If the attacker owns the key, they can basically craft any object that ASP.NET will verify and then accept, which is thoroughly a disaster. In that case, an attacker can craft a malign object to the server to trigger the unwanted deserialization and end up RCE. So here is the demonstration video of the RCE against Umbraco 7. So as you can see, the first step that I'm gonna do is to leverage the vulnerabilities local file inclusion issue to read the contents of web.config. So after reading the content, then I will use the Serial.net to help me to prepare the exploit. And as you can see, that entry point is Umbraco ping.spx. And the command that we are about to execute is who am I. So right now, let's execute this exploit. Okay, so you see that our output of the command has been printed out. Now we are moving to our last bullet point, conclusion. So I know your mind might just might have been overwhelmed with confusion if you do not have any experience using CodeQL before. But I hope that from now on, you will start using it and share your custom queries to the community. In the future, while CodeQL starts supporting more and more languages, it can cover a wider range of libraries and code bases, which means that we are able to cover more targets and do various analysis more and secure more projects. Besides, think of it, CV list is just a bunch of descriptions with no real things to replicate or prevention suggestions to follow in most cases. With CodeQL, however, we are able to model threats, model vulnerabilities, and make each of them generalized by the efforts of the whole community, which is neat. To sum up, CodeQL is a nice tool for finding semantic things, and I'm still learning it as well. So that is all my talk. Thank you all for listening, and I hope that you will learn something from my talk today. Besides, if you have any questions, please leave your questions on Discord channel. Thank you.